Number 6 is a lengthier problem. We have the same boy, mass of 25, still on a scale in an elevator. We're given 3 different scale readings for 3 different periods of time, and we're asked how high up off the ground is he? Which means for each one of these, I want to figure out what his displacement is. Then I'm going to combine all of those together to give an overall answer. I have 3 distinct phases here. Like our kinematics problems with 3 distinct phases, I'm going to break it into pieces and then combine them after. So for phase 1, the upward force of the scale reads 300 newtons. And if the boy still weighs 25, which he does, the downward force is 25 times 9.8, or 245 newtons. I need to find my acceleration. So F net equals ma. Upward force is greater. 300 minus 245 equals ma. We have 55 equals 25a. And 55 divided by 25 gives me an acceleration of 2.2 meters per second squared up. For this time frame, it says that the elevator starts upward. That's implying that V initial is 0. The acceleration is 2.2, and the time is 5 seconds. Therefore, I can find the displacement over that period of time. That'll equal 1/2 a t squared plus VOT, V initial 0. So I'm going to do 1.1 times 25. This gives me a displacement of 27.5 meters over this first time frame. When I have something that's broken into 3 phases, I need to know how fast it's going at the end of the first phase to know how fast it's going for the beginning of the second phase. So I also need V final here. V final equals AT plus V naught, and V naught was 0, so V final is 11 meters per second. Okay, now I'm ready to solve part 2. Part 2 tells me the scale reads 245 newtons. His downward force, which is mg, is 245 newtons. If the scale reads 245 newtons, these 2 forces are balanced. Which means when I do F net equals ma, I have balanced forces. The acceleration is going to be 0 meters per second. 2 things can be possible when it's 0 meters per second squared. It can either be not moving at all, or it can be moving at a constant velocity. And we want to consider which one's true. I know that right before this time frame, it was moving at 11 meters per second. Therefore, for this period of time, it's moving at a constant speed because the acceleration is 0. And that speed is 11 meters per second. So if I want to find distance, I'm going to use distance equals rate times time. It's moving 11 meters per second for 4 seconds, or it's going to travel 44 meters during that period of time. Third phase. Scale reads 190. mg is still 245. Now I can see that the acceleration is down because my downward force is going to be greater. I need to find its magnitude. F net equals ma, and acceleration is 2.2 down. This doesn't mean the elevator is going downward. At the end of the first phase, it was going 11 meters per second squared up. During phase 2, it's going 11 meters per second squared up. So in the third phase, my V initial is 11 meters per second up. But my acceleration is down. What does this mean? When the velocity and acceleration are going in opposite directions, this means it's going to slow down, which is logical for an elevator to do at the end of its path. So when I solve for the displacement, I'm going to use an acceleration of negative 2.2. I want to know how far it goes during this period of time now. So I'm going to use V initial is 11, acceleration is negative 2.2, time is 5. D equals 1/2 A t squared plus VO t. This will equal negative 27.5 plus 55, which gives me positive 27.5 meters. Now for the answer to the problem, I'm going to add these three displacements that I got for these three different phases. 27.5 plus 44 plus 27.5 gives me a grand total